With this video, we're just going to review how you go from absorbance measurements from your spectrophotometer to concentration values of your crystal violet ions throughout the reaction. With your experiment, what you're going to find is the crystal violet concentration, the colour of the crystal violet starts off very, very dark purple, and then as the reaction takes place, you see that purple colour fade. You're using up that reactant, and so you see, you'll actually literally be able to see your reactant being consumed in this reaction, which is very useful to us because we know from stuff we've done in 103 that absorbance is proportional to concentration. So we can say our absorbance measurements are going to be proportional to the concentration of crystal violet that we have in our particular sample. So light's going to pass through the sample from the lamp, through your sample to the detector, and the amount of light absorbed by the sample is then determined by how much light's hitting the detector, and that's displayed as an absorbance value for you. And what you'll notice as your reaction takes place, the crystal violet colour, that purple colour, will start to fade. So your crystal violet concentration will drop as your reaction proceeds. So let's go through a calculation for converting our absorbance measurement into a concentration for crystal violet. And to be able to perform that, you need to know the epsilon value, that's the molar absorptivity specific to crystal violet, and you also need to know the path length. That's the distance the light had to travel through the sample that you're dealing with. So we actually provide those values for you for epsilon times B. So for crystal violet, that's 1.05 times 10 to the 5 molarity to the -1. So we can use that in our calculation here. So let's say after 20 seconds or so, an absorbance measurement of 0.821 was measured. We can use that and our epsilon times B value to figure out a value for the concentration of crystal violet, which in this case works out to be 7.82 times 10 to the -6 molarity for our crystal violet concentration.